Yeah, there's a yellow car, and there's a statue of a service worker, maybe with a laptop and a backpack, and it says technology. Oh, you know what? And actually, here I can kind of we'll get started in a second here. I'm just gonna deal with one thing. All right, and can anyone confirm if you can hear us online?
I hear you.
I can.
Awesome.
I can hear
Wonderful.
you.
Great. And then, yeah, Caleb, we're in the building with the statue, and it says like something in technology, and it's the picture that I put on Meetup is of the door to go into. You go up the stairs, and to the left there's a 217.
I put the picture of that door on Meetup.
Well, I put both. I put two pictures. I put the picture of that door, and then when I was in the room, I took a picture out of the room of the parking lot. But both doors look similar. So yeah. All right. So we will get started. I'm going to share my screen here. Thanks so much for attending. First in person in a couple years. So yeah, appreciate the support there. And let's share and get started. Okay. Neat. And I'm just gonna check the chat and we are good to go. So now, short little introduction. Yeah, welcome to saltlakecity.net. There's our website and little welcome. Am I? Okay. Yep. You are right because I am sharing the Chrome tab, not this PDF. Thank you. So let's fix that. We're going to share this. Great catch. Great catch. I just wanted to see if someone was paying attention and willing to let me know that I wasn't sharing the right thing. So you won that one, Gary. Thanks. So yeah, Kelly's going to talk about spans, and then after we'll have some prizes, and if you want to, chat after, encouraged to do so. And then also, if I don't know, if you're weird enough to enjoy front end, I know Utah JS starts at 7 p.m. in that big room down there. Okay, yeah, code of conduct. Just be respectful. Be, don't do anything that would be frowned upon. So that's that. Couple announcements. All right, so like we may or may not have a speaker for next month. We can always twist arms to do that, but we're always encouraging new speakers. If you're like, hey, I don't know if it would be good enough, don't it's you versus yourself. If you're looking for a topic, reach out. If you know someone who might want to talk but you don't want to ask them, I'm shameless. Let me know. I'll reach out. We'll do something. So yeah, I mean, this is not possible without you, the community. So always looking for more talk ideas. Likewise, if you know a company or an entity that's interested in sponsoring food, let us know, and whatever their asks are, we consider it potentially. And then also,
if there's something you want to learn or want to teach,
but yeah,
you don't want to be the speaker, then suggest me as the speaker.
Yes, that is a great idea. And we have the Discord, so you can just post it on the Discord. That's also a great idea. It's awesome that Rob's willing to lend his time on almost pretty much any topic. So that's pretty awesome. Except COBOL, right? Yeah, we would need at least maybe 40 requests for COBOL, and then maybe Rob would consider it. And then also, right, the community makes this. Spread the word. If there's Slacks, a shared channel at work, a Discord, I just finally posted it in the Utah Forge. I never joined until then, but yeah, if you can think of a place to share it and share our attendance, that's always helpful because that's more speakers, etc. So that's that. We have our YouTube. Typically things take like, I don't know, 2 weeks, sometimes less. Caleb's a machine and getting that stuff up, and we appreciate that. But some trailing there for it to be posted on YouTube. The Discord servers, one of the best ways to reach us. And there's the image there to join that. And feel free to ask questions on Teams. And then also, if you're hiring, feel free to post details in the chat, or you could mention it after as well.
To that end, is there anyone hiring or anyone looking for a job that wants to say hi?
Yeah. I'll take a look at the hiring. You want to say something about the company or anything, or?
Oh, I'm just kidding.
Okay, you're looking. Gotcha. And your name?
Diego.
Diego. Gotcha. Awesome, Diego. And let's see. Nothing in that. Great. We've gotten feedback. Thank you, Steve, that the audio and video are working. Great. And then I am going to hand it over to Kelly, web backend engineer by day, game dev by night. So yeah, give it up for Kelly. Thanks.
All right. Well, now we have to recheck the audio and everything.
Yes, and re-share. I'm going to stop sharing. I'm going to mute myself.
Okay, my mic is unmuted. I have no idea how loud it is, but we will do our best. Okay.
They're right up here.
Oh, sweet.
Some by the plates, some by the pizza.
Okay, is my share coming through?
Yeah.
Okay. Woohoo! Yeah. How far can I stand away? Can you hear me like this? I don't know who's in the chat. Okay.
And you're sharing something else. You're sharing your additional desktop.
Yeah.
Okay.
That's right. Because this is my second one. My slides are over here. I have 2 displays, so
You're not sharing this.
I'm not sharing this.
No. You're sharing Terria or
The
Factoria.
extra slide. Oh wait, is it sharing like whichever window's active? Because I had it right. So let me see. This guy. Yeah. That's what I intended to share. Okay, it's still working. Okay, cool. Okay, we'll see how far this goes until it breaks again. But anyway, oh hey Chad, good to see you. Utilized it with a valid array. So even though I had just given it an array, your IDE will be like, this might be null. That's dangerous. Even though it won't be null because you set it that way, but it doesn't recognize that you started it that way. So maybe terrible is a harsh word. It's suboptimal. We'll stick with that. So that's my not so subtle way of just saying, obviously in 2025, don't use array segment. Maybe it was fine years ago, but. So a span is a new data type that takes on that task and does a much stronger job of it. So you have an array, and the array has an extension on it called span, and that will give you that data in the form of a span. But you'll notice on this second line, it supports implicit casting. So you don't even have to call span if you're passing it to a variable or something like that. But it also read-only span, and they also implicitly cast from arrays, and they also implicitly cast from mutable spans. So, any questions thus far? Are we good? So if we make our method this time, you'll see that we just need one version of it. We don't need to have one that takes special targeting of data. You can just say, hey, give me the span of data that you want me to work on, and you can target the data that you're interested in. So calculate X will pass the entire array into that as a span. And that second one says, I want the span that starts at element 100 and is 50 long, 50 beyond element 100. And then just to show an example, spans work just like arrays syntactically. So you can just iterate them using an index, or you can for each them. And I even forgot a third one here. You can also do a for each ref var X in your span, and that will get a reference access to each of the elements. So you can modify them if that's what you're doing. But that only works on a span. It won't work on a read-only span, obviously. So okay. So this is one of my first favorite mini superpowers of spans, is you can make a span that targets a single element. And I know you might be thinking like, well, I can make an array that targets, one element. But the point is these span types are structs. And so you're not allocating when you're making them. So the fact that you can make a span that targets a single element is nice because you're not paying any cost for that. You can still call a method that takes many values, but still pass it only one value, which is really awesome. So here are some cool things you can do with span, some methods that come along free for the ride. We filled an array with some data. You can target that array. These methods are not in any particular order. In fact, the orders kind of doesn't make sense, but fill is pretty cool. It lets you say, set every element in the array to this value. That's pretty useful. Reverse just takes every element in the span and just puts them in the opposite direction. You can clear it, which sets it to either zeros or nulls or whatever it is the type is that you're the type of the span, or you can sort. And then probably most importantly, at least to me and the kind of the work I do, is you can take any span and copy it to any other span of the same type. So I target the data with a read-only span, and then target a mutable span and copy all the data into it. So here is, in my opinion, kind of the bread and butter of span, is the fact that you can take any span you're given and slice it down to any subcomponent of a span that you want. So that's why when you make a method that takes a span, your obligation is kind of that you're done there, because whoever's calling it, it's up to them to be able to change the size and shape of the span. So what we have here is the first line says slice 5. That means start at element 5 and give me everything to the end, all the rest of the data. Second one says slice 2550. That means start at element 25 and give me 50 elements. So there's a count beyond that. These other ones introduce some new syntax to C#. It's not brand new, it's been out a few years, but this is the range syntax. So this works a little bit differently than slice. This first one says go from 25 to 75. And that 75 is not a count, it's an index. So what you're saying is I want element 25 to 75. That's different than the slice. Again, the slice, the second number is a count, how many elements you want. So then we have one that goes from 0 to 25, but then I show a shortcut after. When you're doing range syntax, you don't need to, if you go into the end of an array, you can just omit the introducing 0. Now these other ones that have the up caret, what that means is that many elements from the end. So what we're saying is, I want a span that goes 60 elements from the back of it, all the way to 0 from the back of it, which is the end. And then that next one is the exact same thing. It's from 60 from the end all the way to the end of the array. So that bottom one shows a more realistic example. It's like, I want 60 away from the end all the way till 5 to the end. And you can mix these. I didn't show an example, but you can say start at element 25 and go to 5 from the end if you need to. So. I don't think it does. In fact, let me talk about that real quick because I have a slide for that very thing. So when you're referencing a span like this, so you have one that has 8 elements. You have 0 through 7, and then you have 8, which is beyond the end, but that's how long the span is. And it's often confusing because when you look at these ranges, you'll typically be told like, oh, the first value is inclusive and the last value is exclusive. And that's partially correct, although that's not the way I like to think of it. Because you kind of run into this issue of like, what if you're pointing to the same element, which wins, the include or the exclude? And in that case, the exclude wins. So I tend to change my thinking of how these indexes work. Don't think of the elements as pointing to the element itself. I tend to think of it as you're pointing to the wall to the left of the element, and that helps you with your grouping of the elements. So so in this example, you'll see that there's 8 elements. The ending of your span points to element 8, which is technically beyond the end of the span. But when you iterate it, you'll go 0 through 7. It's not going to hit the 8th one.
It is 75 ... 25 every story second.
I think so. I if you do it at the time the range is created, I don't know if it checks for you to see if it's lower than it is, but it will blow it up. The span won't take it either way. So, but if you look up a system.range, that has its own whole world, and I think it throws when you try to make one where one's lower than the other. So, yeah, I'll have to double check. But just FYI too, that this range syntax is used other places, not just spans. You can use it on like strings for substrings and arrays for some other stuff, and I don't remember where all it's used, but it's a integrated type, so you can use it in your own data types. You can accept ranges as a type, and you'll get that syntax for free. So there's a type called range, and there's a type called index that it works with. So here, we'll slow down a second. Here's a real piece of sample code to kind of see this kind of stuff kind of work. So what we're doing is we want to take an array of elements and shift them all right n elements, however many we want to move them. And all the elements that move off the end, you want to move them back to the beginning of the array. So we're checking to say, is the span length 2 or more? Because if it's shorter than 2, there's nothing to rotate or nothing to shift. It doesn't make sense. Then we're saying, I want to know how many elements to move everything. If your offset is longer than the array, well, that doesn't make sense. You've just circled back around. So we'll just use modulus to kind of reduce the value down. If n ends up being 0, there's nothing to do, so we just exit. And then we say if n is less than 0 because they provided a negative value, well, we want to shift right the length of the array minus that value. So what we're doing is we take the whole array, reverse it, and then we say, take that same array up to n, reverse just those elements, and then take n on to the end and reverse those elements. And that results in an array that shifted over by some offset number of elements. And then I added an overload for left, which is just the negative of the value you passed. So it's the same result. Any questions or comments on this one? Okay. Yeah, go ahead. That element n to the end. Yeah. So the one before it is beginning to end. Next one's n to the end. And this is where that include exclude is important, because on the beginning to end, it's beginning to end technically exclusive. You're stopping just before element n. And on the next one, it's n inclusive onward all the way to the end. So, but this is a fun algorithm because I look at this and I'm like, isn't that too much work to like reverse the array like 2 or 3 times or whatever? But I implemented some other algorithms and put them in arrays, and it is very close. Like more fancy algorithms that don't do it twice and they hunt and peck for the variable to go the right place. They're not much faster, if at all. Sometimes they lose. So there's something to be said about the cache locality of an array being so efficient that it's faster to just move down them in a straight line than to hop around the array kind of erratically. So if you ever need an array rotation shift algorithm, that's a really simple one to use. So definitely can recommend it. Okay, so one of my favorite things about spans is that behind the scenes, they can reference managed or unmanaged memory, and you don't need to care. When you write a method that takes a span, you don't know that maybe the span coming in came from memory allocated from a C library or something, or from like a graphics library or a font library or something like that. And so in addition to all the niceties I just showed you of being able to work with different sizes, you also just gain this superpower for free. So here's an example of, you guys probably wouldn't be the ones writing this code, but this is the example of some unsafe code that could take some data from outside, put it into a span, and then return that, and that's safe to use. So, and I guess I should have said this earlier, but I guess maybe I assumed it was obvious, but when you're using spans, they enforce throwing exceptions for you. So if you do an index outside the bounds of the span, it'll throw. It'll protect you from doing unsafe stuff. Okay, so let's talk for a minute about strings. And strings are really important because I know a lot of people that work in C#, we tend to work in like web services and a lot of async methods, and probably not going to run into span a whole lot, you know, in your time with C#. But I would say strings are the one area where like everyone runs into problems with the contiguous memory. And so strings are the one area I kind of want to address the most because it has the most utility to kind of like all kinds of C# programs. So I don't know if any of you have ever like run a profile on a really large ASP project at a company, but strings dominate every time, at least every time I've run it. There's always like the garbage collector's like, we've got 1,000 of that object, 500 of that object. Oh, and by the way, I have 185,000 strings that I have to garbage collect and stuff. And so you look at that and you're like, if you're having performance problems, maybe don't make so many strings. So, but I just made this comment here that, you know, substrings are termites at each project, but understanding memory is simply not optional at this point because you have to be able to understand the cost of like each of your actions. So I'll do a little pop quiz really quick. Does anyone know how much memory a string of 2 characters is? What does that cost? You're close. Very close. So I'll tell you, because most people don't know this, because most people don't, you don't need to know this, but every heap object on a 64-bit machine has 24 bytes of overhead out of the gate, even if it's a 0-byte class. And then from there, so if it's 2 characters, each character is 2 bytes, that's 4 bytes. Then you have 4 bytes for the int telling you how long the string is. So 8 plus 24 is about like 32. So yeah, close to 40. That's for a string of 2. And so you'll look at a lot of code and you'll be like, you'll see people like look at a string, take a substring of it, take a substring of that, and get the pieces that they want. They kind of get them all in the right place, and then they do their big concatenation at the end or something, not knowing that they're stressing the garbage collector and just blown through memory like crazy because those tiny strings actually cost a lot more than big strings. Big strings are it's negligible because if you have a 1 megabyte string, the overhead doesn't really matter. So one thing you can do is if you take a read-only span of char in places instead of a string where you don't need to keep the string, you'll start to see some of those gains. So in this example, we have find information, just a made-up method. The first thing I do is trim it because I don't want the spaces on the end of the string. That operation is close to free because I'm not making a new string. I'm not cutting out the spaces, pulling out the string, and then looking at it. I'm just taking the span I have and saying reduce the span so that it gets rid of the spaces on the edges. And another great thing is that it's null safe. So if you pass in null, you just get an empty span. Yeah.
string of 3 is only 2 bytes more than a string of 2. Right?
I think so. I don't know if alignment would fight that, because if you have 3, if your alignment's 4 or 8 or something, it's going to pad out or something. So it may be a little bigger, but yeah, generally, yeah. So if you make a method that takes a read-only span of char instead and work with that instead, you gain other powers for free. In addition to the native memory thing I mentioned earlier, you can now also accept mutable strings, which is something you couldn't really do before. So I'm taking this hello, breaking it into the actual array of HELLO, but I can pass that to find information, and find information doesn't know any better. It doesn't know that one came from a string and one came from an array. So I can change it, call it again, change it again, call it. I don't have to make a new string for each one. I can just modify and then call. So pretty nifty. This is why I love spans. So let's talk a little bit more about strings in general. For those who don't know, all strings in C# and Java are UTF-16. That means 2 bytes per character. And it made a lot of sense back in the day when this decision was made, because in 1999, Unicode 3.0 had almost 50,000 characters. And that means 2 bytes could capture them all. So it kind of made sense to be like, let's just give up on ASCII, and move to 2 bytes, and then we've covered all the characters. So I don't really fault them for making that decision. But the problem is, it's no longer a good decision. Unicode has grown, and as you can see, has almost 160,000 characters. And that means you have to deal with something called surrogates, where you encounter a character, but it's just half of a character, and you have to look at the next character to know what they combine to make one of these higher value characters. And then you also have the issue of big endian versus little endian. It won't be an issue if you're never exchanging data, like if you're never sending UTF-16 over the wire. But if you are, that's something you have to be mindful of, is the byte ordering on your data. So you'll notice that UTF-8 is largely the standard now. Like when you visit the web, your data is going to come in as UTF-8 probably all the time. UTF-8 doesn't have issues with endianness, and it's ASCII compatible. And the good news is C# acknowledged this and added really good support for UTF-8 without breaking the UTF-16 legacy. And I'll show you an example of that. So there's new syntax in C#. If you add a U8 at the end of a string, it's now a UTF-8 string. That's 1 byte per character, obviously, except for foreign characters or extended characters that take up more bytes. But for base set English, it's going to be 1 byte per character instead of 2 bytes. And you can capture it in a read-only span of bytes. And then C# has done a good job of supporting that. So when you call .NET's JSON serializer and call it deserialize, they have methods that accept string, but they also have methods that accept read-only spans of bytes. So you can hand it UTF-8 or you can hand it UTF-16. It doesn't care. It supports both. And then the last example is just going the other direction. It's saying take that data, turn it into UTF-8 bytes. And that's useful if like you're going to be writing to, the disk or a Y or something.
That top line symbol in there. Upset, just cast it to UTF-16.
No, it'll be UTF-8. But if you put a foreign character in there, it'll be multiple bytes. So the UTF-8 encoding, right. So you can arguably handcraft a span of bytes that's malformed, that has like bytes that are illegal that don't form UTF-8, and in which case methods you call will probably just throw an exception. They'll be like, this is bad encoding, bad text or whatever. But as long as you're using that kind, the syntax, that will always be correct. It'll always be valid UTF-8. So, okay. I won't go too deep into these, but these are worth looking at. So .NET has these static interfaces that they apply to their types. So if something is iparsable, these are the methods you're used to. This is what C# has had for a long time. It has parsing from a string, try parsing from a string. But they introduced span parsable, where they have all those same methods, but they support read-only span of char instead. So they're expanding their own core libraries to support all this stuff. And then they added another one called UTF-8 span parsable. So now, in addition to parsing from a string, you can parse from a span of bytes that are UTF-8 and get your object. So it's pretty cool. I have a duplicate side. Well, there it is again. Oh no, this is not duplicate side. I'm just dumb. So these are the formatable interfaces. These are the opposite direction. This is, I have an object, I have like an integer or a float or something, or date time, and I want to write to a span. So if you are writing to either a span of characters or a span of bytes, these interfaces are introduced to allow types to do that. So again, they're making a really concerted effort to say we support UTF-8 and 16 really, really well across the board. So.
To a bunch of things, and then date time got missed. By
Yeah.
just a few days. And code base got locked down because there were some real complications with the way everything is formatted with cultures and everything.
Yeah.
And a few days after they finalized the code base, got affected, so it'll be in anybody.
Yeah, it's making it to 11. Geez.
Can you kind of repeat the gist of the comment for the people that were online, in case they couldn't hear it?
Which comment?
Just about the date.
Oh, what he was saying. I'll do a bad job of it, but you're saying the .NET team was working on some parsables. They missed some for UTF-8 parsables, datetime specifically, and they got it in after the deadline, and we won't see it till .NET 11 is what you said, because .NET 10 is coming up. What, November? Well, is that next month? Oh my goodness, man, time flies. Yeah.
Is there such a thing as a UTF-8 char?
No, it's just a byte. They didn't make a type for it. Yeah, there's the rune type. I've never gotten it to work the way I want it to work. I don't know if that's a good answer, but yeah, you just have to use like special kinds of enumerators that know how to walk a UTF-8 sequence and that kind of stuff. So okay, so this is really cool. I really like this this method. They have a new method in .NET called string.create. If you want to make a string, but you want to dodge all the complexities of allocation, if you're, again, doing some high performance code, what string.create does is you tell string.create, I want to make a string that's, in this case, 7 characters long. I know ahead of time how long it's going to be. And what string.create does is it gives you one opportunity. It says, I will give you the span to write that data in, and then it'll become a string. And there won't be any copy. That's the benefit. There's no copy that's done. And the reason they're able to do that is spans are what's called ref structs, which means they basically can only live on the stack, which basically means you can't capture it. Like if you have a span coming in as your parameter, you can't stick that into your class or some other thing. You can't keep it. It's limited to the scope. So I'll go over this in 1 second, and I will go over also what I just said about ref structs in here just a minute. So on this code sample, we have string.create, 7 characters long. That's how long my string is going to be. This next parameter is whatever you want it to be. It's called a state variable. It's just data that's going to be passed from the outside of this call to the inside of this delegate. And the reason they do that is, again, to avoid an allocation. And the way they do that is whenever you make a lambda or a delegate and you capture state, you've made a closure, and that becomes an object. And that's an allocation that happened kind of invisibly. So what they do is they say, pass in whatever you want. We will make sure it gets in there. And then this is a lambda, not a closure, because I've marked it static. So basically, if you ever doing a code review and you see someone using string.create, make sure they mark it static. Because if it's not static, they're doing it wrong. But so here's what's happening. The RGB is the state. So this delegate has the span of char. I should have put the types in there. That's my bad. I made it less clear. But the span is the span of char, the data you'll be writing to. And then state is whatever I passed in. RGB was passed in as a value tuple. So they're all passed in kind of together. So inside this method, I can access the span, and I can access my state to form the hex color. So what this is doing is taking red, green, blue, and making the HTML color code, the pound and the hex, the 6 hex digits. So any questions on that? I know I kind of threw a lot of you all at once, but. Yes, I think it's either called T-state or T-arg. I forget which, but it's just there for you, the caller. It's the only reason it exists. It's just there to dodge an allocation. Yeah. So this whole setup here has one allocation. That's the making of the string. No other allocations occur. So that's why you would use it. If you have a case where you're doing a lot of string building or heavy concatenation, you want to avoid that. You're like, I know how long it's going to be. I might as well skip to the answer. Then you just do something like this. So
I'm back compared to string builder.
string builder will be a lot more allocations because you have the string builder class, which is inside makes a rope and it has a bunch of like connected arrays. And then when you finish it and say, take the builder, make a string, that's another allocation. And then you have to garbage collect your string builder. So it's like you go from like 1 to 5 plus all your appends and however many you do. So just depends. Okay. So let's talk about memory AT for a minute. When this was first announced, I thought I was going to use it way more than I do. Turns out it's not a very useful type. Maybe that's a little mean, but I don't use it very much. But it is useful. There is a situation what it's made for. So as I said earlier, you cannot do this. You see, I have a class and I just put a span in there as one of the members. You'll get an error, and it will tell you field or auto implemented property cannot be of type span unless it is an instance member or of a ref struct. So span itself is a ref struct. You can put it in a ref struct, but then that outer ref struct has the same rules as the inner ref struct, so it has to stay on the stack anyway. So this is why memory of T exists. It has a very different purpose than span. So what you do, if you really need this ability, you use something called a memory data type. And this is more of a container and not like span. You can think of memory as a span factory because this is how you use it. You can take your data, you can point it at an array or some other memory compatible object, and then you say, give me the span on the memory type dot span. You'll spawn a span in the moment that you need it. So this is useful if you're doing like async methods or other stuff because you can't have local spans in an async method because in async methods your execution leaves and that's illegal for spans and stuff. So memory kind of has its purpose, but again, I don't use it a whole ton. I won't spend a whole lot of time on it, but it's similar to span in that you can slice it, capture arrays with it, and that kind of stuff. So. Okay, we'll talk about some fun features real quick. They recently updated params to support like everything. So you can do params. Well, first off, does everyone know what params does? Y'all like params? You guys ever use params? It's a great keyword. Okay, so what params does is says, I want to accept any number of, in this case, ints, but it could be strings, it could be whatever. Before the update, you could only take an array. So you'd have to do int, you do params, int bracket values. And then when you're calling do the thing, you can just pass in as many as it wants and it'll just put them all into an array. Very nice feature because it makes your syntax, your methods clean looking and everything. But in the recent update, they made it so that you can do params list, params enumerable, params, you can do span, you can do read-only span. And I'm just here recommending, if you're not going to capture the data in some way, just use span because you'll pay nothing for the allocation. It'll all just be thrown on the stack and then call in the method. I think if you knew ahead of time, I'm going to capture these values and keep them as a list and put them in a place, maybe. But you're right. It's kind of a stretch. I probably wouldn't use lists very often for that. Use a linked list. That's the best answer. Okay. Here's another really fun scenario. So you have a dictionary. You can't use spans as a key in a dictionary because again, spans, they can only live like, you know, in a method scope essentially. So if you're making a dictionary, you have to use string. Well, what if you're in the situation where your dictionary does lookup by string, but you've loaded, you know, 100 megabytes of text and you're going through and grabbing pieces of it and saying, is this in the dictionary? Is this in the dictionary? Is this in the dictionary? You don't want to have to pay the cost of every single one you're looking up. You're hydrating a string, comparing, oh, it's not there, and you throw it away. And you're just churning through your garbage collector because you're just checking to see if the value is there. Well, the .NET team like saw this coming and prepared for it, which is why the .NET team is so awesome. So they have a new feature called Get Alternate Lookup. You just tell the dictionary, hey, I'm going to ask you about your keys using a different data type. And so now I can use a span and ask it if it has that type. Okay, another fun one. Stack alloc. Before span, you had to use the unsafe keyword to use stack alloc. Stack alloc is just a way of saying, I need some memory from my stack space that's just temporary. I'm going to use it in this method and then exit the method and then that stack space will go away. Well, with the introduction of span, you no longer need to use unsafe. So this is the same method as before. This is the string create example, but just done a different way. What I've done is I said, let me borrow 7 chars off the stack. Let me fill it with some stuff. And then let me just make a string from that span. So this one does have a copy, but there's still no allocations. You still avoided allocations by doing this. So if you're ever in a situation where you don't know how much space you need, here's an alternative. There's a type called array pool, and you can say, hey, I need an array of at least this size, and it will give it to you. And then when you're done, you just say return it to the pool and it'll go back. So you can have lots of methods sharing the same group of arrays.
So refresh my mind.
Yeah.
It will give you an array of at least the size you asked for, so do not trust that length will be the number you asked.
Yeah, that's right. So I'll repeat what he said. So one thing with array pool that you have to be careful of is that the rent method, you're specifying a minimum. You're saying how much memory I need at least, but the array you get back may very well be much bigger. So you need to be careful and check the length of your array before doing stuff. So good catch. And I run some tests on it. I think they're always powers of 2. Like I think it rounds up to like 512 or 1024 or something. But yeah, it's a minimum, not a specific number. So, all right. Memory marshal, just some other useful stuff. Again, this used to be the realm of like unsafe code, casting pointers and doing dangerous things. Now it's all safe code. Now it's stuff you can do without much concern. So in this example, we've read a bunch of bytes. We say, hey, I know that these bytes are actually a bunch of longs, or that could be a complex struct, or it could be any other data type. And you just say, hey, give me a span of long from these bytes. And the nice thing about this is it takes care of the math for you. So it's like bytes are obviously easy, but if you were going from a struct that's 24 bytes to a struct that's, 40 bytes, it will look at the overall length and say, okay, there can only be this number of structs in that array. So it does the math for you so that you get a safe length of a span. And then this last one, converting to bytes is so common that they just made a special method for you. It's like you can take any span and say, okay, give me the bytes. I'll take the bytes of this type. Lists are guaranteed to be arrays. Like that's how they're implemented, and .NET will never deviate from that. So there is a special method that will give you this span. It's called collectionsmarshal.addSpan, and you pass in a list. It's also null safe. The reason they put it here and not like on the list class itself is just so that you acknowledge that this is something you don't want to do this if you're modifying your list or iterating your list. You want to get the span, do your business, and then let the span go. So they put it in an external method just to kind of signal that. But again, lists are always internally they're always arrays, so you can get spans from them. Okay, so this one, I imagine the fewest, like next to nobody in this room will need this feature, but it's good to know it exists just to plant the seed in case you ever run into a situation where it might come in handy. But this is a now safe way to make static arrays, meaning an array where you know the size ahead of time and you don't want it on the heap. So this is really confusing. I don't like this. I wish they would change it, but I don't have that kind of power, so we just gotta deal with it. But what this is saying is IP address v6 is an array of 16 bytes. That's what this says. I don't know why you make a private member like that. The name you give it doesn't even matter because it gets ignored here soon. But what it lets you do is do this. So I can make an array, or make a IPv address v6, and I can just start accessing elements on it like it's an array. But that's all in the stack. This is not on the heap, unless of course the struct itself is on the heap, but that's a different story. But these inline arrays are compatible with spans. So if a method takes a span, you can pass it an inline array and it'll convert for you automatically. And you can slice. I didn't show it, but you can take the IP address v6 instance and do slice the indexing range syntax on it and get a span out of it. So pretty cool feature. Kind of low level, kind of advanced and that kind of stuff. All right, so the last thing I have to show, this is just a screenshot of my repo. I work on a repo called jawbone.sockets. Jawbone is my kind of game development library, and sockets is a special networking library I've been working on. And half the reason I made it was because spans are a thing. Like once spans came into existence, I was like, oh, I have a lot of ideas to do to do cool stuff with spans. So the one beef I have with like the current socket class in .NET is that you pull it up and there's like 9,000 methods and it's like got tons of legacy code and all this other stuff. And I wanted a socket to be like this. This is all a socket needs. I can send and you pass out a read-only span of your bytes, and I can receive and you just hand a mutable span of the buffer you want to write to. It's like, that's it. I don't want 400 ways to send and get my data. So I just kind of leaned into this and just kind of made a library that kind of built around it. And the idea behind this library is that all your actions are as close to zero alloc as possible. So I'm not going to show you the details right now, but in general, understand that the IP addresses in this library are all structs, and they all support accessing the structs by byte or by short or by uint or whatever chunk of data you want. And this is generic, and it takes a specific kind of address. And so you either have a socket that's specific to IPv6 or specific to IPv4, and you don't have to worry about like heap allocations for your addresses because the IP address in .NET is like very allocation heavy. There's like multiple layers to it. So anyway, that is it for my slides. Any questions or anything about anything? All right, that's it. Thanks for watching.